solving 1- and 2-step equations. First thing we need to know is what's the difference between an expression and an equation. An expression is a mathematical phrase made up of numbers and variables connected by operators such as addition, subtraction, multiplication, and division. So if you look at 3x plus 2, there's a variable multiplied by a number and added to another number. Equations, however, are statements formed by two expressions related by an equal sign. So if you look at this, we have an expression on the left, an expression on the right, and an equal sign in between. Solving equations talks about how we find the value of a variable that makes the equation true. So if I look at the equation, x plus 2 is 5, I can intuitively know that 3 plus 2 is 5, so x has to have a value of 3. However, when I look at an equation like negative 4x plus 5 equals negative 7, it's no longer that simple. So we need to think about an equation like a balance scale. Okay, equations are balanced just like a scale is. So we're going to set up balance scales to solve equations. We're going to use green rectangles for positive x. The white rectangles will be negative x. The red squares are positive 1, and the white squares are negative 1. If we look at x plus 2 equals 5, we need an x tile, and we need 2 1s, and we need 5 1s on the right side of the scale. So what's on the left side of the equal sign goes on the left side of the scale. What's on the right side of the equal sign goes on the right side of the scale. Now, the idea is we want to get the x by itself. So how do we get rid of these two positive ones? I need to create some zeros. So for each positive one, I need to put a negative 1. Now, if I do that on the left side of the scale, I have to do it on the right side, because otherwise the scale is not balanced and will tip. Now if I look, I've actually now got a few zeros. So what did I do to both sides? I added negative 2 to each side. What's left? I've got an x on the left, and I've got 3 positive 1s on the right. So x is negative 3. So what strategy did we use? The first thing we did was we determined the opposite of the constant term on the side of the equation that had a variable. For instance, the opposite of the positive 2 was negative 2. And then I added that to both sides, and then I simplified. Can we use a similar strategy to isolate for the variable in 4x equals negative 8? Absolutely. I've got 4 x tiles, and they go on the left side because they're to the left of the equal sign. And I've got 8 negative 1s. Now I'm going to stack them side by side with my x tiles. I've got 4 of them so far, and 5, 6, 7, and there's my 8th negative 1. Now the interesting thing here is I want to know what each x is worth. I split each of my x's up, and I gave each one 2 negative 1 tiles. So if I look at what each x got, each x got a negative 2. So the solution to this was x equals negative 2. Now what strategy did I use? I figured out how many, I had 4 x's, and I had 8 negative 1s, and I split it into 4 groups. Now splitting into 4 groups is division. So I divided both sides by 4. Can I use a similar strategy now? If I go back to something similar to that first page, I've got 4x plus 5 equals negative 7. Absolutely. So I said I have 4 x's. So I'm going to put them there. Positive 5. And the right side is negative 7. Now, I want to get the x's by themselves. So in order to get the x's by themselves, I have to get rid of these positive ones. So I'm going to put the opposite on. We just talked about that strategy. So I'm going to put 5 negatives over here to match up with each of my positive 5s. But if I put 5 negatives there, I need to put 5 negatives onto the right side. Now, on the left side, you'll notice I didn't end up with any 0 models. Or sorry, on the right side, I have no 0 models. But on the left side, I have lots of 0 models. I've ended up with 5 zeros total. So now, what am I left with on the left? I'm left with 4 x's. And on the right, I was left with negative 12. So the first thing I did was add the opposite of the constant term. And now I've got my 4 x's left. Uh-oh. I'm running out of space here. Because I really do want to stack these because I've got 4x is negative 12. And I'm going to share those negatives with each of my x's. 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to split them up again. So split each x up and share those tiles, and each one ended up with negative 3. So x equals negative 1, 2, 3. Finally, what's our strategy? Again, same thing. We determined the opposite on the constant term side, so we figured the opposite of positive 5 was negative 5, and we added it to both sides. We simplified it, and then we divided by 4 to solve for x. And before you come to class tomorrow, please do page 10, number 1 to 3 in your workbook. Thank you.